Hello everyone, hope you are doing well. Welcome to the online platform Civil Technobricks. Guys, here we will tune for instantaneous decoding of conceptual knowledge in the field of civil engineering, where study elaborates decoding the earth to build a better world. Today, we will go through the core concepts of engineering geology, consideration in highway alignment and design in view of civil engineering. So, civil engineering, which is a dependent on the engineering geology branch, plays a vital role in planning, designing, and constructing safe highway infrastructure. There may be a subsurface investigation or there may be a surface investigation. So, from subsurface structure to surface stability, we have to work in the engineering geology. Geological investigation helps identify suitable terrain, stable foundation conditions, and construction feasibility based on the availability of nearby rock surface or the soil surface. Highway alignment must consider rock type, soil conditions, groundwater availability, and slope stability. Improper geological assessment may lead to landscapes, landslides, pavement failure, settlement, and drainage issues. So, civil engineers use geological data to ensure economical, durable, and safe transportation systems. Roads are the static structures on dynamic earth. So, two parts, compact rock and incompact rock. So if we are planning to construct a roadway on the earth surface, it may be a soil surface or it may be a rock surface, then there are two phenomenon: compact rock availability for the foundation and incompact rock availability for the foundation. The result is viewed in the picture. So rock mechanics, which is the fundamental strength, is always less than breaking strength. Here picture 1, quartzite type of massive and hard rock is available, which provide a stable foundation for the roadway embankment, so that the surface of the road is stable and compact. In the second picture, shell like stone, which is laminated and weak in the strength, is available, which provide the unstable foundation for the embankment of the roadway. At the result, it make cracks for the surface of the road, so which provide the incompetent rock or which competent road surface. So importance of geological investigation in highway projects is most important, which provide the information about subsurface soil and rock conditions along the highway routes. Site investigation helps identify unstable slopes, weak formations, and fault zones too. Proper geological assessment minimizes maintenance cost and construction risk also. Investigation supports safe design of embankments, cuttings, bridges, and retaining structures. Highway planning is most important point, which becomes more efficient when geological hazards are identified early and mitigated. Checking the alignment criteria, or we have to decide the alignment criteria for any roadway. We have to study the earth crust or we have to study the subsurface earth. So highway alignment selection, which is the most important point as per the civil engineering domain. Highway alignment should avoid weak geological formations, marshy lands, landslide prone areas also. Alignment selection depend on topographical characteristics, soil stability, drainage conditions, and construction economy. The stable alignments and straight alignments reduce construction difficulty and maintenance problems also. So geological mapping helps us to identify suitable corridors for safe highway construction. So we have to use stable rock surface, not unstable, which is parallel to strike. So proper alignment improves safety, riding comfort, and long-term pavement performance. So we have to study subsurface activities, strikes, fault planes, their nature, their texture before finalizing the alignment. When we cut the drill, or if we take the sample from the subsurface investigation of any type of roadway, then the sample is seeing like that, where n number of layers of rock, soil or combined rock soil texture. So at the basement there is a granite which is a hard rock. Above that, with reference to the lithological characteristics, sandstone is available. After that there is a unconformity which is shown in the orange color, having the zigzag nature. Above that there will be a overburden of soil or rock fragments. So the drill records the most complete structural data with reference to its texture, size, depth, everything. We have to trace the beds over distance with reference to the mining data, so that we can decide the selection of any type of highway alignment over to it. Correlation is that matching key beds across boreholes. So if we are dealing with the subsurface investigation, that are the part of topography or the terrain analysis. Terrain analysis is most important, which helps engineer to understand slope conditions and natural landforms also. Mountainous terrains require careful design to prevent slope failure and erosion. With reference to the flat terrain, they are easier for highway construction but may face drainage and flooding problems. Remote sensing and GIS techniques are used for terrain evaluation and route planning, where proper terrain assessment ensures that safe and economical highway alignment, which is based on subsurface investigations. So what is the role of remote sensing in the highway alignment, mapping or subsurface investigation? When we are using the remote sensing tool to sense the geographical or topographical or subsurface strata based on some color coding system, then we can mark the fault plane, strikes, deep, everything with reference to that macro structure. So aerial photography, which is a tool used for remote sensing or surveying point of view, which identify the erosion along the weakness plane or weaker planes. Aeromagnetic survey, where detecting buried rock types just like gabbro versus granite. So granite is a hard rock, gabbro is not a hard rock, so we can prefer granite rock for the embankment point of view or stability point of view. Also mapping formation boundaries via gamma radiation, so we can emit the rays by using some emitters, so that the structural member or the geological characteristics which are beneath to the earth surface may targeted, and we can get the information in terms of vector data just like the tabulated format. So soil and rock properties directly influence highway foundation stability and pavement design, which will be collected the data based on the remote sensing technique. Weak soils may cause differential settlement and pavement cracking. Also the weaker rock plays same the role. Hard and stable rock are most important formation, provide better support for highways and structures. Geological investigation helps us to select suitable construction material and stabilization methods. Geotechnical mechanics, which is the important part which shows the stress strain diagram, where strain or displacement or deformation on the x-axis with reference to the stress, where differential forces are acting on the same part. So the black curve at early, which is in elastic range, after some part it may be in plastic flow, after some part or at the before end point it gives the ultimate strength, and after the ultimate strength it may get rupture point or it may get crack. Means the when we started the applying the force at a point, that point must have to sustain that force. After impacting a large amount of force at the same time with reference to its bearing capacity, it may get deformed, and that deformation plays the elastic range, plastic flow, ultimate strength and rupture point at the end. So roads apply compressive stresses, excavations release confining pressure. So structural geological features are most important point for the same. So geological structures such as faults, folds, joints and fractures affect highway stability. Fault zone contain weak material that may cause settlement and structural instability. Jointed rock masses increase the risk of rock fills in the hilly roads or cut slope region. Engineering geological mapping helps avoid structural weak zones during alignment planning based on that stress strain diagram. We have to check the actual tectonic plates and its nature, which is below to the subsurface. If we are doing the survey manually with reference to any total station like instrument, then we have to check the surface activity only. But with reference to the remote sensing and GIS techniques, we can measure or we can play the role of controller or the receiver on the surface of the earth, so that we can check the subsurface activity, rock nature, rock type, everything, to prevent the hazard situation. So what is the danger? Surface measurements may be misleading. Means we didn't rely only on the surface investigation. We have to go for subsurface investigation too. Simultaneously, surface and subsurface investigation provide us the actual data which can prevent the future hazard. So slope stability is the most important point with reference to the tectonic plates and the rock layer. Landslides occur due to the weak geological formations, heavy rainfall and improper slope cutting. So we have to complete the survey activity based on that criteria. Geological investigations helps identifying unstable slope and potential failure zones below to the subsurface. Retaining wall, rock bolting, drainage systems, these are all the methods which are used for soil stabilization or slope stabilization. Landslide prone zones where gravity sliding is there. If the weaker strata of rock is available, or we can say that a sedimentary type of rock or metamorphic type of rocks are available in the hill region, then during rainy season there may be a huge landslide due to the cracks available in the same. So detached block may get slipped down on the highway which are constructed in the hilly regions. So removal of support on deep slope triggers gravity sliding, which is based on the mechanics of folding by gravity. The highway cutting and filling portion may get disturbed due to that slip planes which are in orange color. So that slip plane may get integrated or may get minimized with reference to the vibrations also beneath the earth surface. So the highway cuttings and excavation point of view, highway construction often requires excavation through soil and rock formations. Geological conditions determine excavation methods and slope support requirements through the retaining walls. Rock cuttings in fractured formation may lead to rock fills and instability. Engineering geology helps us to optimize excavation design and minimize environmental impact. Here the image which shows that the wedge failure geometry, joint set B and joint set A. Here there are n number of rock layers which are in black color, orange color and yellow color. With reference to that joints or fault plane or the fractures within that, in summer season the whole rock may get heated with reference to the temperature and generates cracks in between them. In rainy season, the huge amount of rainfall will be there and the whole cracks are filled by the water, and the above layer to that crack may get settled down and landslide will occur. So temperature integrates the instability in between the rock layers, and rainfall plays the role to integrate that rock cracks so that the slope nature will get slides down with reference to the gravity on the earth surface or nearby earth surface. A large joint dipping into a highway cut is a potential landslide site or location. So what are the common geological failures? So highway construction often requires excavation through soil and rock formations. Geological conditions determine excavation methods and slope support requirement. They are maybe based on the fault plane, fold plane, deep strike. Rock cuttings in fractured formation may lead to rock fills and instability. So engineering geology plays role to optimize excavation design and minimize the environmental impact so that the common geological failures may be prevented. Here two pictures are there: differential compaction where 0% compaction is there, and fault rectification. So first image, 20% compaction on both sides of the uplift rock layer where the exact flat surface of road is constructed above the surface. At the same time, there will be a tectonic plates or n number of rock layers are available below to that road surface which is constructed, but after some vibrations beneath the earth surface, or we can say that the existing fault may impact or slide down or slide up due to the vibrations, we see the active faulting. So these are the common geological failures, or we can say that the road cracks due to that active faulting. With reference to that damages, geological investigation identify suitable construction materials such as aggregates, sand and stone. Quality of material improve the pavement strength and durability. Nearby material sources reduce transportation cost and project expenses also. So unstable materials may lead to premature pavement failure. Material testing required, and which ensures that compliance with highway engineering standards. So drainage and hydrologic geological point of view, also we can check and we can study the type of rock just like sandstone, shale, so that the water is percolating from that sandstone and it may show the capillary rise or capillary fall action. Shale does not. Shale is a hard rock with reference to the sandstone which can't allow the water to enter in it, so that the whole water which is seepage or percolated through that sandstone layer which flow above to the shale and below from the sandstone towards nearby cut region where the road surface is there. Also we can provide the interceptal drain for the same, so that the whole seepage water which will be collected and transferred through the artificial drains. So hydrogeological parameters also plays the impact role, or environmental conditions plays the impact on the life of the roadway. So highway project should minimize environmental damage and hydrological disturbances. Geological investigations helps to reduce unnecessary excavation and slope cutting. Suitable highway design improve long-term infrastructure performances, which must balance safety, economy, environmental protection in highway projects. So subgrade competence is based on the actual availability of rock and its type. If quartzites and marble is there, so high competence, because these type of rocks are hard rock. They are most suitable for pavement, embankment or any type of roadway pavement. Secondly, sandstone, which is a moderate competence. They are not as much as hard, just like quartzite and marble. Then third, shale type of rock, which prone to plastic flow under load, where low competence and plastic flow is there, means we can't prefer the shale type of topography for the subgrade of any type of highway or any type of railway embankment also. Here the massiveness is equal to strength, means thick beds are more competent than thin laminations. So laminations are due to the shale type of rocks, so we have to go for hard type of rocks just like marble, granite, basalt, quartzite, which provide high competence for the subgrade. With reference to the modern techniques which are used to improve the bearing capacity of soil or bearing capacity of rocky surface, if the granite type of hard rocks are not available but we have to construct the roadway alignment, then we can prefer the geosynthetics, which is the artificial support, where we can improve the existing soil layer or existing rock layer and its bearing capacity or load bearing capacity. So geosynthetics acts as a man-made bedding planes with high tensile strength. Here the graphical representation shows that the stress diagram with reference to the normal and shear. So normal stress on the x-axis with reference to the shear stress on y-axis. So the orange graph which shows the reinforced strength and the yellow graph which shows that the failure part. So if we use the geosynthetics, then we can improve that failure to the reinforced strength by using that geosynthetic reinforcement, which is a add-on or addition to minimize the failure, or we can say that to integrate the efficiency of the existing soil layer or rock layer which is not as much as hard. So geosynthetics are the additional material which is inserted through some powder technique or through some net or through some sheets into the soil layers. Engineering geology is essential for safe and efficient highway alignment and design. Geological investigations help us to identify suitable terrain, stable foundations, and hazard prone areas. Proper understanding of soil rock, drainage types, slope conditions improve highway durability. Integration of geology with civil engineering principles ensures that sustainable transportation infrastructure. Also, we can use the advanced materials just like synthetics or geosynthetics. Stay tuned, guys. Happy learning.